let's look into the one more topic, that is type conversions. It is a process of converting one data type to another data type. That is, we can convert to large data type to small data type, and we can also convert from the small data type to the large data type. So here we are converting one data type to the another data type. So that process is called as the type conversion. So we have the data types like integer, float, character, and etc. So for example, converting one data type to another data type, nothing but like a float to integer, or integer to float, or integer to character, character to integer, etc. So this is the process of converting one data type to the another data type, that we call it as type conversion. We can also convert from the large data type to the small data type. So when we convert the large data type to the small data type, at that time some data will be lost. But when we convert from the small data type to the large data type, at that time no data will be lost. So let's see some of the examples for the type conversions. So first example, I am declaring n variable with integer data type by using that, and I am declaring the value of n as 4.567. Now this 4.567 I assign to the variable n, and this n is declared declared with the data type integer. Now printf %d and n. So %d format specification for the integer, and I want to print the value of n. So when I print the value of n, in the output I get it as 4, because here n I declared as integer. So whatever the float point we give here, it is taken as the integer data type only. So in integer data type only it prints the integer, it does not print the float values. So we can't see the point and something like that, we can't see. So this is, I declared it as the integer, so that's why the output it is printed as 4. So here we are converting the 4.567 to the 4. It means we are converting float value to the integer. Nothing but we are converting float data type to the integer data type. So this is a process of converting from the one data type to the another data type. So this is called as the type conversion. And in the same example 2, I declared another variable n with the data type float. It means n can take the float values, but n I am declaring as the integer, that is 10. So it is an integer, not a float pointer. So printf for %f and n variable. So %f is a format specification for the float data type. I want to print the value of n. So when I want to print the value of n, it should be printed 10, but it is printing something like 10.000 and 000, because I declared the n variable as the float data type. So that's why it has printed the pointer numbers also. It has printed up to the 6 decimal points, because in float it prints the 6 decimal point only. When we use double, it will be different. So indirectly we are converting the integer to the float. So we are converting integer data type to the float data type. So this is also a best example for the type conversion. Now let's see the types of conversion. In types of conversion, we have the two types. One is implicit type conversion, and one more is explicit type conversion. So let's see the implicit type conversion. It is a process of converting one data type to the another data type internally by the compiler. So by the compiler only we are converting the one data type to the another data type. So that process is known as the implicit type conversion. So let's see the example here. First one is integer to float conversion. Let's see the program for this. So we are converting the integer to the float. This conversion comes under the implicit type conversion, because this conversion is done internally by the compiler. Now it starts, first we have to include the header files, then after it starts with the main function. So int main, open the block, I declared n variable with the data type float, then after clear screen. After the clear screen, n equal to 10. So I am assigning the value 10 to the variable n, but this n is declared as a float. So this is same as the previous example. And the printf %f, and I want to print the value of n, and get cs return 0, close the block. So in the output we will get it as 10.000 and 000, because this n I declared with the float data type, but the value which I gave is 10. That value will be printed along with the decimal point because I declared with the data type. So this is a process of converting integer to the float. So this integer is converted to the float value. Next we have the float to integer conversion. So in this float to integer conversion, first we have to include the header file. Then after it starts with the main function and open the block, and I declared one variable n as the integer with the int data type, then clear screen. But n I am declaring it as 4.567. So 4.567 value I assigned it to the variable n, and this is a float point value. Now when I print this, the value of n with the %d format specification, and then after get ch and return 0. So when I use this in output, I will get it as 4, because though we gave the float point to the variable n, but this n is declared as the integer. So that's why it takes only the integer value. It takes only the up to the pointer, nothing but it takes only the 4, and it does not take the 5, 6, 7. After the decimal point, it does not take any number because we declared n as the integer data type. So here we are indirectly we are converting the float value to the integer value. So this is called as the float to integer conversion. So these are the simple programs. Next we have the character to integer conversion. So we can also convert the any character to the integer. So first we have to include the header files. Then it starts with the main function. Open the block. So I am declaring one character with the variable ch. So ch is declared with the data type character. Then clear screen. So this ch is equals to, in the single quote I am writing a. So character can take only the single character at a time because I am using the char data type. So when I use string, I can take the collection of characters, but I want to get the value of a. So this a I am assigning to the ch variable, and this ch is declared with the with the data type char. Now in the printf %d and ch, so we are converting the character to integer. We are converting the character to the integer. So here this character I want to print the value for a. So %d, then get ch. So after get ch, return 0 and then close the block. So in output I will get it as 65 because there I use the format specification %d, and for each of the character we have the ASCII code. So ASCII stands for American Standard Code for Information Interchange. So for each of the special characters, or for each of the alphabets, either it is a lowercase letters or the uppercase letters, there some ASCII code will be there for each of them. So for a we have the number as 65. So when I use their %d, the value of a will be printed. Not only for the a, you can take any special characters like hash, ampersand and question mark, or small letters like lowercase letters also you can take. So for each of them you will have the ASCII code. So when I use their %d, the value of that specified character will be printed in the output screen. So this is about the conversion of character to the integer. And also we can convert the integer to character. So integer to character conversion, first we have to include the header file. Then after it starts with the main function. Open the block, and I am declaring one variable n with int data type, then clear screen. Then n is equals to 65. So I have assigned the 65 value to the n. So printf, I am printing the %c. So we know that %c we use for the character. This is a format specification for the char data type, and this % is for n. So get ch, return 0. So when I am printing this %c, that value will be taken. So for the 65 value, the character is a. So 65 is the ASCII code for the character a. So that's why in the output screen a will be printed. So it is same like the before one, but reverse to this. So this is a process of converting from integer to character data type. So here 65 is converted to the a, nothing but integer is converted to the character. So this is about the implicit type conversions. And then let's see the second type of conversion, that is explicit type conversion. So this is also known as the typecasting. So it is a process of converting one data type to another data type externally by the compiler. So by the compiler externally this will be converted from one data type to the another data type. So this whole process is called as the explicit type conversion. Let's see the syntax for this. So in the syntax, so data type, then variable name. In the braces we will write the data type, variable name, ended with semicolon. And another way for this type of conversion is data type, or we can also give the expression in the place of variable name. So where data type is a target data type. So this data type is the target data type. We can give any data type in the place of this. And these are the two syntaxes for the explicit type conversion. Let's look into the examples for the explicit type conversion. First example, I am declaring variable a with the integer data type, and a is equals to, within the brace, data type int. I am using the int here, and the value I am giving it as 7.34. So we can also give the variable, we can also give the value directly, we can also give the expression. So in the output this it will be printed as 7. So this is also the conversion of from the data type, one data type to the another data type, but here the syntax is different. So when I am printing this, when I am taking the data type int, so this 7.34 will be converted to the int data type. So this float value 7.34, when I convert it to the integer, it becomes 7. So in the output 7 will be printed. Then same in this example 2, I am declaring n variable with the float data type, and n is equals to float of 2 plus 3. So here I am using the second syntax within the brace data type, and we can also give the expression here. So float, so 2 plus 3 nothing but 5. So when I am this 5 is an integer, so that is float of 5. So 2 plus 3 nothing but 5. When I am using a float data type, this integer will be converted to the floater. So when I write this integer in the form of floater, we get it as 5.000 and 000. So this is a conversion of integer to the floater. Now let's see the typecasting. Let's see the program for this explicit type conversion. So the same above expressions I am using it in the form of program. So int main, before this we have to include the header file. Int main starts with the block of code within the curly braces. Int a, I am declaring variable a with integer, then clear screen, is equals to int of 7.34. So this 7.34 float value will be converted to as integer, because I am using the int data type here, that is 7. Next printf, when I am printing this %d, this value will be printed here, and integer in the brace I am writing the int and 7.34. So this float value will be converted to integer, that integer value will be stored in the variable a. So when I print this, in output it will be printed as 7. The next one more for the float, just I am writing in the program way, see in the C program. So before this we have to include the header file, and in main float a, declared variable a with the float data type, clear screen, and a is equals to float of 5 into 2 plus 6. So first this will be evaluated. So 5 into 2, first into will be evaluated. So 5 into 2 is 10, and 10 plus 6 is 16. So 16 will be converted to as float. So when I print this, printf %f and a, that 16.000000 will be stored in a. So at the time when I print this, that value will be printed. So after that program get ch and return 0. So after this in output I will be getting as 16.000 and 000. So that value will be stored in the variable a, and when I print that, so that value will be printed onto the output screen. So this is about the type conversions. It is very important. It can be asked in exam for directly for the 10 marks. So you have to explain the implicit type conversion and also explicit type conversion with the example. So, and along with the example, the program should be written compulsory.